Hi, this is Dave Hammer. Today we're going to forge a railroad spike knife with the high carbon steel insert. We'll start with an old railroad spike that I picked up at a tailgating. I want my insert to be about a quarter of an inch wide. I don't have any 1095 that width, but I've got some 1/8, so I'm going to cut two pieces and put them in together. I need to sand off the rust, and I should have done that before I cut that split, but it worked out okay. And they are two pieces for the insert. I'll just put them together and forge weld those into the slot. I'm going to cut a groove for that insert. Start about halfway down the spike and cut my groove about halfway through the spike. Just use a hot cut, centered. You won't see all the forging on this project. You'll see an example of all the types of forging that's necessary. If I had a video with all the forging, it would be much longer. So I'll show what kind of forging we have to do, but not every second of it. That groove, because of the hot cut, has a pointed bottom in it, and I want the bottom to be flat, because I'm gonna flatten my inserts into it. So I just use a bar about the same width as the inserts are going to be, and push it down in there. And actually, this is actually deepening this slot also. This is just mild steel. Then we fit in the insert. I've have them clamped into vice grips. Just force them in there. The inserts are a little wider than the slot, which is a good thing. Moving it around there so I can hit it. I'll be forge welding this. I'll be using borax as a flux. Here I'm just setting the inserts. I'm hitting on the back there to set them down in, and then the sides, locking them in some more. Clean it up a bit. As I said, this is just regular 20 mil-team borax. It's a laundry powder. They're sold as a laundry powder in grocery stores. Take it up to welding heat, bring it out, and forge it. Just light hits to begin with. This takes several heats to get this weld where I want it. Just flux it between each heat. Then I square it up to the original dimensions. I probably should have used a hot rasp off some of that excess on the inserts, but I didn't. I just forged it down. But it welded in pretty good. Later I'll grind that side off just to make sure that there isn't any flash that just bent over and didn't forge weld in. And I'll show a way to tell that you got it all off. Next is to cut the grooves for the cubic twist. This is basically a groove on each of the four sides down the middle, and this will be deep also. Probably each groove will be close to a third of the way through. It seems like a lot, but if you want the cubes to pop out well, it needs to be a lot. This is a drawing of the cross section, what it should look like. for all those grooves. So we cut grooves on all 4 sides, and then we go around. I don't make a full groove cut at a time. I might make 3 or 4 iterations going around, down one side, then down the next side, then down the next side. And then finally, when they're all as deep as I want them, I just go back and even out the width of the groove as it shows when you look at it. After it cools and you've cleaned it up a little bit, you cut the cubes. I use an angle grinder with a zip disc, kind of a modern hacksaw. I have been called a hack. This is how deep that you make those cuts. You make them from the far side of each groove to the far side of the next groove. And you do this on opposite corners. You can measure these out if you want. I used to. I don't anymore. I just eyeball them. They don't have to be perfect squares to look good. Next is to take a nice even heat and then make the twist. I was too worried about the camera here, and I didn't keep track of how straight I was holding that when I was twisting it. It's not difficult to hold that and get a straight up and down twist. This is a 360 twist so that the insert comes back around relative to the railroad spike head the way I want it. If you want a lesser twist than that, you would just adjust where you put the insert. If you have trouble with it, you can use a wooden mallet or a leather mallet on a piece of wood to straighten it. Here I'm using a smithing magician to isolate the handle from the blade. This is just a fuller, round top and bottom fuller. And every time you hit that, or every other time you hit it, you should turn it. You can see I've narrowed that to about 5/16. After it's cooled again, I grind any flash off of the insert side. To make sure that I have all the flash off, I just use a little bit of ferrochloride and etch that. And if it's not the way I want it to be, it'll show very clearly. This here should show basically straight lines showing the different kinds of metal. If you see blotches, you have not taken off all the flash. Next is to come up to just under a yellow or a yellow heat and start widening that blade. I didn't get this blade, I didn't forge it quite as wide as I wanted it. It doesn't look bad, but if I would have liked the blade a little wider. I'm using the peen there. That 1095 is as hard as woodpecker lips, so it's kind of hard to move. If I'd have been a little more aggressive, I would have gotten exactly what I wanted. I used the horn to lengthen. The horn is a fuller on the bottom side. Bring it over. Basically, what I'm forging this to is a flat bar 1/4 of an inch thick. The width and the length is going to depend on how much mass there is available. But when I start forging that blade, I want to be working with a 1/4 inch thick bar. Next, I'm going to forge a sharp angle on the tip side of the spine. This is the back away from the cutting edge. The reason I do this, actually when we start forging the cutting edge, we're forging a taper down from the spine to the cutting edge, and that's stretching that and pushing that blade around. This angle will help that blade straighten up. And if the angle is long enough or acute enough, it'll actually be part of the hammer design later. So we're going to true it up again. We're going to true it up to the 1/4 inch thickness, and then we're going to start tapering the blade from the spine to the cutting edge. When you do this, you have to keep in mind and watch that you're forging from on both sides, and you got a nice even taper from both sides on the back from the spine. This looks like it'd be difficult, but it's not. A little bit of practice. Take some hammer control. I'm not saying it's easy, but I'm saying anybody who has luck forging can learn to do it. Forge both sides evenly. The spine should stay, during this particular step, the spine should stay a 1/4 inch thick all the way to the tip, except maybe at the actual very tip. But we're putting in the taper from the spine to the cutting edge now. In another step, we'll put in a taper from the transition to the tip of the blade. There you can see my spine is pretty straight all the way. The next step is going to be to put in the taper from the transition area, the handle, to the tip of the blade on both sides, and you have to forge on both sides. So what I'm doing is I'm tapering this from the handle to the tip, and leave that tip a little heavy. You don't want that to get thin on you. The cutting edge at this point in time, what I'm striving for here is a little less than 1/8 of an inch. You'll see that in a second. You can see it there. It's pretty consistent in width, the cutting edge is. You can see the taper on the blade from the transition area to the point. At this point in time, this forging is almost complete. I just need to bend the handle. There's a better picture of the taper from the transition to the tip. The tip should be almost 1/8 of an inch thick. There's the cutting edge, and you can see that's pretty consistently about 1/8 of an inch in width, and it fattens up at the transition area. I bend the handle by just whacking it over a piece of wood. You could lay it on there and hit it with a leather hammer or a wooden hammer also, and if you can't get what you want, that's what I go to. This is a leather hammer. I didn't quite get the curve I wanted on the handle itself, so I set it on there and put a little curve in it. You can straighten it up easily if you go too far, so don't be bashful about hitting it. It's going to bend at the weakest point, and in this case that was the transition area. Next is to normalize that whole forging. Bring it up to non-magnetic in the forge slowly, let it soak for a little bit, and then lay it on a soft brick or some kind of surface that doesn't draw the heat out of it. This is a finished forging. After it cools, use a wire wheel or a brush to knock off the scale, and then the next thing I do is straighten out the spine. I grind it straight. I want that back to be straight to start with. That's a 3 by 132 inch belt grinder. Probably's got 60 grit on it or something like that. We're going to do most of the grinding before we heat treat. Remember, we forged a little thick. We're going to take it down in a set of iterations to about a 32nd from what we want the finished size to be. Next, I'm going to grind the shape of the blade. I'll flatten the bottom out a little bit, curve the blade around. The end was a little messed up, so I shortened it, but just grinding that end off and shaping the blade to match the length. We need to do this before we do our grinding from the other direction. Keep a can of water by and keep that blade cool. You don't want that blade to get hot enough so it discolors. This is a 2x60 grinder, and I'm going to use it to grind in a drop point, which is just that little curve that's on the spine up near the point. Looks like it makes a big mess in there, doesn't it? So it just takes a couple minutes. Just be sure you keep it squared up with the spine, the blade, the rest of the blade. There's literally hundreds of different shapes you could go for on any knife blade. Here I'm going to grind in a choil. I'm not sure how to pronounce that. It might be coil. Just a round area there, kind of like that. This is using this new sander I just made, the small roller sander. Go back and touch up again to get it close to the finished dimensions. This is going to be kind of a convex grind, as opposed to a hollow grind or a straight grind. I've got a little work to do on my grinders to set up before I'm confident of doing a good straight grind, and a lot of practice to do before I'll try to do a hollow grind on a good knife. Okay, after you've got it close to the final dimensions, ramp it up to non-magnetic slowly in the forge, and then bring it out and quench it in oil. This is what I did. Now, my heat treating is very primitive on this because I just haven't done a lot of it. Done a little bit, not with knives, and it's different with knives. There you can see that the oil um, actually stuck to the softer iron a lot, and not much to the 1095. Okay, to draw it back and temper it, I just, again, this is crude, but I just used a little torch and heated it from the spine until colors ran to the blade that I wanted to see. And the color I was looking for was blue. Is this 100% correct? I don't know. It's just what I've done. So I'll learn more about this later. I sat in I missed a demonstration by a good friend of mine where he talked about heat treating. And he's a professional knife maker. And the next step is removing whatever scale it got on there during that process, and then doing the final grinding. Again, this will be a convex grind as opposed to a straight or a hollow grind. Here I'm using my finger as a backing. Then on to the buffer to polish. I use black rouge to start, and then I use either green or blue, whatever I grab first, for the final bright polishing. Again, you got to keep your knife cool. If it starts to get too warm to hold on to, you need to cool it. You don't want it ever to get color. So it's best just to polish for just a few minutes or just a few seconds and then cool it again. Be very careful when you're using a buffer or wire wheel. They're very dangerous. It doesn't seem like they would, but they can grab and throw the knife or whatever you're working on. If you end up seeing scratches that don't come out with the buffer, with polishing, I'll go back and I'll use succeeding grits of sandpaper, wet or dry sandpaper, up to 600 until I get them out. And then back to the buffer for the final polishing. Again, be very careful. It's easy to have an accident. There we go, that's the finished product. If you want to go back and look and see where the insert line is, you can take your polished knife and use a little bit of ferric chloride to etch it, and you'll see very clearly where the original iron is from the spike and then where the 1095 came in. If you want to get rid of that, you just go back to the buffer. Thanks for watching.